So how do you do that? Well, here's how you do that. In the back of most books, what you will find, let me move this out of the way, is a table. Now, I just printed this table out. You don't have to memorize it. You'll be given a chance to use one multiple times. I'm going to zoom in a few times so you can see it up close. We're really worried about what's here at the top. And you'll see that it says water vapor pressure. Okay? Now, water vapor pressure. This is the pressure that is caused, oops, let me move that back, I'm sorry, by water at different temperatures. So here you'll notice, for example, at a temperature of 0 degrees Celsius, water has a pressure of 4.6 mmHg, or 0.61 kPa. The pressure of water at 5 degrees Celsius is 6.5 torr, or 0.87. And so basically what you do is you look up your answer on a chart and you subtract it out. Let me give you an example. Let's say that you had a tube that has a total pressure of 780 torr when bubbled through water at 20 degrees Celsius. What is the pressure of the dry gas? Whew, and I need to zoom out just a little bit. I forgot I had zoomed in. All right, if you'll pause the video and give them a chance to write that down, then I'm going to show them how to do it. All right, here's what we're going to do. Magic numbers, we're going to take those out. 780 torr, 20 degrees Celsius. It's really all we need to know. So I'm going to take the eraser and take the problem out. But I'm going to add what we learned just a minute ago. Total pressure is going to equal the pressure of the gas plus pressure of water. Now, how do I know it has pressure of water? Because it said it was bubbled through water. Okay, so the total pressure, well, that says 780 torr. That was from the question right there. And it said it was 20 degrees Celsius. Why would they give us that? Well, if you take this chart and you look up water at 20 degrees Celsius, I'm going to zoom in again so that we can all see the answer. At 20 degrees Celsius, you will see that right here it says 17.5. Top of the up here says it's in mmHg, 17.5. That is what water has a pressure of. Okay, so 17.5. So the pressure of water is 17.5 mmHg, or we'll just use the word they did from the question, torr, because mmHg and torr are the same thing. This is what they want to know. How much is the pure gas? Well, it's simple subtraction. You're going to take 780 minus 17.5. So I'm going to go ahead and do it with my calculator just so everybody can see it. 780 minus 17.5. 762.5. And I'm going to zoom out so everybody can see everything. My apology again. Simple subtraction. 762.5. 762.5 torr. Simple math. Okay? Let's do one more. Let's say we were doing our experiment and with the battery again, but let's say we just had one big tube that set over the top, and we collected inside. You're going to have pressure of hydrogen gas, you're going to have the pressure of oxygen gas, and you're going to have the pressure of water because you bubbled it through water. Let's say it was done at 800 torr and 18 degrees Celsius. All right, well, the first thing you're going to do is 800 torr. And all we want to know is the dry gases. What is the pressure caused by the gases you caught? What you're trying to do is get the water out of the equation. So, magic thing is 18 degrees Celsius. So I'm going to look up 18 degrees Celsius. That is 15.5 torr. 15.5 torr. Now let me say this before I go on quickly. You'll notice that this column is in millimeters of mercury, and this one is in kilopascals. I could do all the same math in kPa. Now, you don't have to memorize this. You'll be given one of these when you're asked to use it. Use the table that says water vapor pressure. Now, you'll also notice there's some things down here that we don't need. So we're not going to worry about these at the bottom. But we use the water vapor pressure. So basically, all I have to do is take the 800 torr minus 15.5, and I have the answer. Okay? There'll be 784.5 torr. That's the total pressure that just comes. Now, you can notice there's a difference here between these numbers. It's slight, but when you're doing calculations with it, it makes it really, really important on what you're doing. So you want to make sure at all times you have an idea of what's going on. Now, so how do we use this? Why did I show you all of this? Well, let's take an example such as this. A gas is collected over water. As soon as you hear those words, or bubbled over water, you got it, at 22 degrees Celsius and a pressure of 720 torr. If its volume was 7.3 liters, how many moles of gas were present? Now, if you'll pause the video real quick, let them catch up to me, and then we'll, what's the problem? All right, as soon as you read this question, a lot of people, when I first teach us, the answer they want to come up with very quickly is 22.4 liters. Got it, bang, got it. Because that's the number he taught us. Remember, that has to be at STP. Are we at STP, which is 0 degrees Celsius or 273 and 1 atmosphere? No, we're not at those, so this does not apply. So we can't use that piece of information right now. Okay? So what we're going to do is we're going to take PV equals nRT. Now it says that your pressure was 720 torr, but it was collected over water. So what we're going to do is we're going to take this chart and we're going to find what water is at 22 degrees Celsius. So let's see if we can find that. At 22 degrees Celsius right here on my chart is 19.8. So I'm going to go off to the side, and 720 minus 19.8. And I'm going to use my calculator to make sure I get all the right answers. 720 minus 19.8. 700.2. So that is the number. That's the dry gas, because that's what's causing the pressure. We had to get water out of the equation. Now at 22 degrees Celsius, to do pivnert, I have to be in Kelvin. So I'm going to add 273.15, so that's going to be 295.15, so I'm going to use the right value this time. I'm in torr. Well, that doesn't help me. That means I'm going to have to change that as well. So let's go over here, 700.2 torr. 760 is 1 ATM. And so 700.2 divided by 760 is 0.92 ATM. Alright, so now I have atmospheres, so I'm going to use 0.0821 for my R. You already know how to do this. Volume is 7.3 liters. My X is going to be there, and that is in the unit of moles. And the question asks for moles. So all I have to do is solve. So to do that, I'm going to divide by the 0.0821, and I'm going to divide by the 295.15. So I'm going to divide by both of those. All calculator work. So it is 0.92 times 7.3 divided by 0.0821 equals divided by 295.15 equals 0.277 moles. Now, the math that I'm doing here is not too difficult. You know how to do all of this. The point of this lesson is to make sure we understand that whenever we bubble something through water, we actually pick up some partial pressure from water. The gas gets wet, and when the gas gets wet, when you have a pressure, it actually includes water. So if you can subtract out water's pressure, then automatically you have the dry gas. So that's why the gas law is used like this. So you have the true pressure of the gas, what was its volume, what was the R value, and what was the temperature. Simple mathematics as you go to work through them. These problems can be as difficult or as easy. If they wanted grams, then you would just take this answer and railroad track and change it to grams. Application using partial pressures. Good job. Keep up with me. You'll get to practice some of these here pretty quick.